Welcome to a lesson with Dr. Powell. Let's take a look at the graph of this function using derivative information. The first derivative, we want to see where the first derivative changes from positive to negative or negative to positive, because that would be places where the slope goes from positive slope to negative slope, and we might get a maximum or a minimum. So let's go ahead and see what we can do with that. Now, the potential places where we might be changing sign, again, are domain issues or jumps, or places where the function output is actually equal to 0. The only option here, since this is a nice function with no jumps or domain issues, is just where it's equal to 0. This function is equal to 0 precisely when x is equal to pi thirds. Looking at the graph, cosine x is shifted down on this interval from 0 to pi. We notice that we're going to have a positive derivative on this side and a negative derivative on that side. So it looks like around pi thirds we have positive slope, then negative slope, so that we actually end up getting a max. Now this max happens at a flattening, since this derivative is 0 precisely at that point, so it'll flatten. So it'll look like this. In fact, if we look at the second derivative, notice this is negative sine x on the interval from 0 to pi. Looks like this, which is always negative, meaning it's always going to be concave down, meaning on the whole interval, we're concave down the whole time. Now, if we want to know where we have maxes and minimums, we better really look at the endpoints too, because endpoints can also yield places where the function's the lowest or highest. Okay, so let's take a look at this right here and think about that for a minute, and kind of how we want to get this. We need some essential points here to maybe work with. The key points would be the ends as well as the pi thirds. Let's get some coordinate pairs with those. So we get 0, we plug in 0, we end up just getting 0. Plug in pi thirds, what would we get? With sine of pi thirds is root 3 over 2. So we get root, so it looks like we'll get, so we'll get root 3 over 2 minus, and then pi thirds like that, which, we could adjust it a little bit. Basically, I just plugged it in. Okay, but however that is. So we get a y value point right here. We also get another one when we plug in pi, the other endpoint. So pi, sine of pi is just 0, but we end up getting a negative pi halves. Okay, so negative pi halves, this is root 3 over 2 minus pi 6. Actually, the y value of this is actually, okay, that's going to be the maximum, right, which we saw there. It's going to be flattening. We can kind of draw this graph roughly. So we start at 0, 0. Pi thirds, we build to a peak, the y value at that point, and then we come down when we get up to pi, which would be a little bit closer over here. So pi, we're going to be right there. Now looking at this graph, we notice we have a maximum, we have a minimum, a local minimum. Here we have a local minimum. Local means nearby, it's the lowest point. Local maximum means nearby, it's the highest point. However, we could also say that this one is the global minimum because it's the lowest minimum overall, and this one is the global maximum, as well as being a local maximum. If something's global, it's also local as well. Of the function, we can see that from the graph. Thanks for watching.